Correlation or linear regression. What is correlation and how do I use the best fitting line? Some words that you want to make sure that you understand by the end of the lesson is what is a scatter plot, what is positive correlation, what is negative correlation, what is relatively no correlation, and what's a line of best fit. Scatter plots are graphs that have a bunch of points on them to represent data. Here is two scatter plots. Here is two scatter plots. And here is a scatter plot. Well, what are these scatter plots? These scatter plots are plots that describe information that has positive correlation, because if I would draw a line through them, my line would have positive slope. This line would be called a best fitting line. And I can repeat this process for any graph that has a bunch of data points. So in this graph, I could draw a best fitting line down, same way with this one, and this one has a best fit line, all right? And the difference between these two graphs is that these graphs have negative correlation, and the previous graphs have positive correlation. So we have negative correlation, positive correlation, we have lines of best fit, and now we get to a problem that I'm not sure how to draw my line. I mean, these couple points might be down, but these 2 points are up. I am just not sure how to draw my 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 line of best fit. So when I'm not sure how to draw my line of best fit, this means that there is relatively no correlation, because I don't know how to draw my line of best fit. Okay, how can lines of best fit, um, how do I use a best fitting line? Why do we go about doing this? Well, here is an example of the y-axis is the United States oil production in thousands of barrels daily, and here is on the x-axis I have my uh, years, time. So I could draw a best fitting line. I know it's not perfect, but I could draw a best fitting line that says it looks like the data is going down like this. Now, if I would want to write an equation um, that would be, in slope-intercept form, it would be something of the nature y equals mx plus b, and I would need to figure out my y-intercept. The only problem is that right now my x-axis, I'm at 1960. So here would be 1950, here would be 1940, and all before I know it, I'm off the paper. So what we have the ability to do is to manipulate the graph and the data. So what I can do is I can take this data, I can cut it off right here, and I can say that, hey, let's let 0 be equal to 1965. And if I do that, I can use my y equals mx plus b. I can draw my line of best fit, and it looks like it's going to go up about through there. All right, and I know it's not the best. I'm just doing the best job I can. So it's looking like my B is going to be around 12,000, and I have Y equals, I need a number for M, X plus 12,000. Well, it's looking like I'm going down from 12,000 to 7,000. So that's looking like I'm going down 5,000. And it's looking like I'm going over from 0 to 45, and so my slope is negative 5,000 over 45. So this slope simplifies to be negative 1,000 over 9. So my intercept would be y equals, my slope-intercept equation would be y equals negative 1,000 over 9x plus 1,200. Now, sometimes we just care about the information towards the end. I'm not sure what was going on here um, with all this data to cause it to go up and down. But maybe I only care about the data from here down. So I could create a different graph. And so here's my x-axis, here's my y-axis, and notice that here 0 is 0 is equal to 1985. So this would be 1985, and this would be 1990. And once again, I could try to write an equation for this data using y equals mx plus b. So I need a line of best fit, and so I try to draw a line that's going through most of my data, all right? And there it is. And it's looking like I'm crossing halfway between 11,000 and 10,000. And so it looks like my y-intercept is 10,500. And what's my slope? Well, if I go from 10,500 down to 7,000, that is going down 3,500. And then how many am I going over? I'm going over from here to here. That's 0 to about 24. So I'm going down 3,500. I'm going over 2,400. Excuse me, I'm going over 24. And that simplifies to be negative 875 over 6. So now I know my equation is y equals negative 875 over 6x plus my y-intercept of 10,500. I hope you saw how we can use a best fit line to write equations to describe to describe the points on a scatter plot, and I hope you understand the difference between positive correlation, negative correlation, and relatively no correlation.